This session is about number of combinations and factorial, and actually we will look in this topic in more details when we talk about probability later. But now you have to get used to the symbols, and this topic will be useful when you learn binomial theorem later. Now you can see something like that, the n factorial. Okay, we call n factorial. Actually, you can try to find this is also there's also a button for that in your calculator. I'll give you an example was to explain the meaning of this symbol. 3 factorial means 3 times 2 times 1, which is 6. And then 5 factorial means 5 times 4 times 2 times 3 times 2 times 1, which is 120, etc. Okay, and then you can see another symbol which is written in this form, NCR, or in symbol it is written like that, NCR, or like that. They just mean the same. Now for the definitions or for the formula for calculating this one, it is n factorial divided by r factorial n minus r factorial. Okay, and therefore, for example, if you have 5c2 like that, it is 5 factorial divided by 3 factorial. Oh no, sorry, it's a bit, I do it a bit slower. 5 factorial, r is 2, okay, therefore 2 factorial, and then 5 minus 2 factorial, which is 5 factorial, 2 factorial, 3 factorial. Now in this case, instead of expanding 5 factorial at 5 times 4 times 3 times 2 times 1 like that, and then do the cancellation, we can do a little bit quicker like that. Now look at 5 factorial. 5 factorial actually means 5 times 4 times 3 times 2 times 1, right? And actually, if I just look at this part, this is 3 factorial. Therefore, if you are familiar with those symbols and concepts, 5 factorial actually can be written as 5 times 4 times 3 factorial like that. And then 2 factorial, 3 factorial, and then these two cancel each other. And then we have 5 times 4, 2 factorial means 2 times 1, which is 2. Therefore, 10. And you can also find the values by using your calculator. Okay, you can see the symbol here. Right. Then you can use this button to do these calculations like that. Right. Now then I'm going to tell you what's the meaning of 5c2. Now actually this one we are calculating something called number of combination. I use another example with smaller number. For example, I have 3 C2. Okay, you can imagine that there are 3 available objects, and then we would like to choose 2 from them, and then we would like to see how many combinations are there. A, B, C, we can choose A and B, A and C, and B and C. B and A are just the same, okay? If we just focus on how many objects that we want to choose, okay? Therefore, from 3 available objects, we need to choose 2, then there will be 3 combinations, A, B, A and C, or B and C. Now, if I calculate this one by using the definition, which is 3 factorial divided by 2 factorial, 3 minus 2 factorial, okay, 3 factorial, 2 factorial, 1 factorial, and then if you still remember, 3 factorial can be written as 3 times 2 factorial, 2 factorial, 1 factorial is 1 actually, and then we cancel this one, and then you can see the results match with each other, okay? And then we will come across this later in the topic probability. And one more thing is that we have 0 factorial. Later you will know that for convenience we set 0 factorial to be 1, okay? Now here then we will look at some examples as concerning about the use of the NCR symbol. Now here in this example, without using a calculator, calculate the foreign expression. This one just for you to practice the definitions of NCR. Of course, in your examination, you will use your calculator instead of calculated by hand as anyway. Now 6C2, okay, which is 6 factorial, okay, NCR, this is N, okay, 6 factorial, this part will be 2 factorial, and then 6 minus 2 factorial, okay, and then 6 factorial, 2 factorial, 6 minus 2, 4 factorial, and then we write 6 factorial as 6 times 5 times 4 factorial, 2 factorial, 4 factorial, we cancel these 2, and then 6 times 5, 30, divided by 2 factorial, 2 factorial is 2, therefore we have 15. And look at one more example, 8C3, okay, 8 factorial, 3 factorial here, 8 minus 3 factorial, and then 8 factorial, 3 factorial, 5 factorial. We write 8 factorial, 8, 7, 6 times 5 factorial, 3 factorial, 5 factorial, okay, divide these two, and then 8 times 7 times 6, 3 factorial is 3 times 2 times 1, and therefore we cancel these two, therefore at the end we have 56 here. Now the last example, we have to solve the equations NCn-1 plus NCn-2 equals 10. Okay, we just follow the definition. N factorial n minus 1 factorial, we take R to be n minus 1, and then here n minus 1 factorial, okay, plus n factorial divided by n minus 2 factorial, n minus 2 okay, factorial equals 10. Now then we simplify n minus 1 factorial, n minus n plus 1, therefore which is 1 factorial plus n factorial, n minus 2 factorial, this is 2 factorial equals 10. Now if you look at how we can rewrite the factorial, okay, if it is 8, we have 8, 7, 6, 5, 4, 3, 2, 1, right? And the number here, which is 1 less than 8. Therefore, in this case, for n factorial, it can be written as n times, the next one will be n minus 1, 1 less than this number, blah, blah, blah. Therefore, just factorial, okay, n minus 1, n minus 2, n minus 3, etc. up to 3, 2, 1. And therefore, in this case, you should be able to see that we can do some cancellation later. And similar to the second term, this one n factorial, but if you can see that the denominator consists of n minus 2 factorial. Therefore, this one we write as n times n minus 1 times n minus 2 factorial, okay, n minus 2 factorial, okay, 2, which is 10. Therefore, you can see that we can do the cancellation here. We can do the cancellation here. Therefore, at the end, the equations become n plus n times n minus 1 divided by 2, which is 10. And then we can just rewrite and simplify this one. Multiply the whole equation by 2 to n plus n squared minus n equals 20. And then we have 2n squared plus n minus 20 equals 0, which is a quadratic equation. You can just solve what you have learned in the topics about solving quadratic equations. And then we have n plus 4. Oh, no, sorry. Should be n plus 5, right? And then n minus 4, 0. Therefore, in this case, we have two possible answers, n equals minus 5 or 4. But according to the meaning of NCR, which is about the number of combinations when choosing objects, therefore we cannot have a negative number of objects for for selecting, right? Therefore, in this case, this one is rejected, and we just get this one 4. And in this case, you can, if you get the meanings of NCR is the meaning of number of combination. Therefore, in this case, this NCR, both of them will be non-negative integers. Okay, and this R must be less than or equals to n. You cannot greater than n, because n is the total number of available objects, right? Okay,